Good morning to all. I am Dr.S.V.Mahesh Kumar, Associate Professor, Department of ECE, Bharat Institute of Higher Education and Research. Today we are going to discuss about Embedded Design Lifecycle, EDLC. Embedded systems are used in many real environment applications. It is a software integrated in a hardware to solve a particular real environmental application. So the embedded systems have basically two units, the hardware unit and a software unit. We should decide about the hardware specifications and software specification. After that, we can integrate the software and hardware to solve the particular solution. The device should be upgradable and the device should be solved a particular problems completely, and the device should be real-time oriented. So the various aspects are there. The hardware and software partitioning is performed, and then other aspects like RTOS also used to achieve a real environment result. In this session, we are going to discuss about a complete embedded design life cycle. Let us start the presentation from what is EDLC. It is a completely analysis method to solve a design-oriented issues. And why we are using this EDLC, and what are the objectives of EDLC, and what are the different phases of EDLC, and what are the different models such as Waterfall Model, and then Waterfall Model with Backflow, and the V model and spiral life cycle model, and various models are also discussed in this session. This is the reference for this presentation. Let us start with what is EDLC. EDLC is an analysis, design and implementation based problem solving method for embedded system product development. We need to design a particular product to solve a particular issue. So we need to concentrate about what are the architectural models are there. We need to analyze how to satisfy the requirements, and we are implementing a model to solve this issue, and we are testing that model. After that, we are integrating it, and we are developed as a product, and then we are getting continuously, we are monitoring the product status, and we are upgrading the product according to the monitoring process. So it is completely a cycle. So we are going to discuss what are the necessity of EDLC. Why we go for EDLC? It is essential to understand the scope and complexities involved in any embedded product development, because embedded product is the real environmental product. So we need to analyze what is the scope for that product, and what are the complexities, real environment complexities are involved with the product development. And it is interaction and activities among various groups of product development sector. So the product development means basically architectural has two units. First one is hardware development unit and the software development unit. A hardware software duality is important in embedded design. So it is an interaction between various groups of product development. And then what are the things we are going to do using this EDLC cycle means we need to follow a project management, system design and development, system testing and quality assurance. So the project management means we need to design a product according to the requirements, and it overall what are the steps are involved, and how whether the system is satisfying the customer requirements or the industry requirements, and then what are the design flow about this, and what are the specific hardwares or softwares are used for that. Everything is managed through this EDLC cycle. The objectives of EDLC to ensure high quality products and deliver to user. So end user is an important aspect. You need to develop a device to satisfy the requirements of a end user. So from the design itself, we are concentrating. So we are designing a product according to the requirements of the end user. After that, we are validating, we are testing the product, and we assure a quality of service, and we are assuring this quality of the final product, end user product. So this is the main motto of our EDLC. And then risk minimization and defect prevention in product development. So it is achieved through project management because various aspects, what are the hardwares are used, what are the softwares are used, whether the hardware and software is matched, whether according to the requirements, whether the software requirements are matched with the hardware requirements and other memory requirements, everything is managed and the risk is minimized and the defect prevention is also achieved through this EDLC because we need to give a effective system to solve a particular issue. So before that, we need to check whether the system actually solves all the problems related with the real environment and whether the hardware is suitable to solve all the environment, whether the software, application software is synchronized with the hardware, whether it can access the all elements and whether the entire system is working on a particular environment. Everything should be tested before provided to the end user. What is the benefit? By applying this, we can maximize the productivity. These are the important factors in technology management. So these are the parameters. So first one, market demand. So we need to design a product according to a market demand. What is the requirement? Whether the product has any scope in the market. So everything we need to analyze thoroughly before producing a product. And the second step is cost control. Is it eliminate the unnecessary cost related to this? So you need to solve an application. You need to choose each hardware module according to our requirement only. And moreover, we are designing, you're writing application software also according to the requirement only. And then on chip memory and other what are the costliest things are there are designed only based on the requirements. So in this way, we can eliminate the cost. What is the third thing is you need to assure the quality. So quality is the factor how our system working in a real environment, whether the system actually solve all issues, whether the system can actually sense various inputs from the environment, whether the system controls all devices which are connected to the system. Everything should be assured through this quality assurance. And time to market. Once a product is developed, it's a time to market. Whether it is quality product, we need to sell it in the market. So it's a time to market. It's also decided based on their management scheme. Know how protection, how the device is working in the environment, whether it satisfies the requirement and it has a market value, and then market continuously it can be sustainable. So we need to provide the other upgrading and other facilities also. So entire thing is managed through a technology management. These are the phases of EDLC. The process starts with innovation. Before producing the product, we should innovate it according to the requirements. The requirements of the practical scenario, you should map the requirements with technical aspects. So various technical aspects are there. So based on the requirement, you should map what is the hardware is suitable, whether the hardware salvage, whether the microcontroller family is suitable for this application, whether the application program solve all issues, whether the application software access more in devices, IO devices. Everything it should be through the innovate process only we can design a project or we can develop a product. So before that, we should innovate it and we need to construct the modules. That is the important thing because it is a requirement is the only factor. So you don't have any specific device hardware, don't have any information about any specific hardware and software. So it is the idea. So based on this requirement, you need to innovate the idea and prototype, and then you need to analyze all the parameters. This analyzing is the next one. You need to analyze what is the suitable hardware, what is the suitable hardware description language for that, and what are the elements, what is the suitable microcontroller, and what is the memory, what is the data memory size, what is the program memory size. According to solve this issue, what are the things are required, you need to analyze it before designing. So design is the process. You need to design how the modules are interconnected, everything you need to design it. So before implementation process, you need to design what are the inputs, what is the first module, what is the second one, and what is the final output, or what about the output status, what is the range of output, everything you need to concentrate that. These are known as design specifications, you should concentrate at. After that, you need to implement it as a product, and then we already discussed about various hardware software design process and decision making, partitioning. What is the memory required? What is the memory? How much memory can be allocated as a data memory? And how much memory can be allocated as a program memory? And then what are the loops are related with this? What are the accessing modules? What are the IO devices? Everything you should to included in the design model, and then you need to implement. After implementation, you need to verify, you need to test it, and then you need to test for a real environment scenario also. Also before a final testing, the individual models, individual hardware models also tested using test vectors, as well as a software model also tested, and then throw the debugging tool, and then the compilation is there. Finally, the code is application code is integrated in a chip. So you need to verify whether the device or system solve all practical application requirements. So you need to verify, and then deployment is the next step. After that, we need to support a continuous upgradation process. We need to include the modules are required. We need to alternate the programs, that is upgradation. So we need to provide the support through continuous maintenance as well as upgradation. If the process is over, it's for a long time, suppose we need to completely rearrange the things, we need to completely design a new model, then that is known as the stages retirement. That stage is the final stage, and then we go for a next product. So this is the cycle, different phases of EDLC. So these are the different phases from innovate to retire. So innovate or conceptualization, you need to assume the requirement as a concept. So the first step is statement of needs, that is requirement. We are getting the requirement from the end user, or we are getting the requirement from the companies. We are working for that. And then planning. The planning means this is the phase according to solve all the requirements, designed requirements. You need to work out for that, and you need to plan for what are the steps are involved in hardware design, and what are the steps are involved in software design, what are the modifications need to be done, what are the things to be added, everything. So in the planning, we need to concentrate about planning for next phase. What is the next phase, and what are the requirements for that? How we can achieve the next phase. And then resource planning. You need to decide about how many hardware teams are required to solve to design a hardware elements, how many software teams are required, and what about the size of a testing team. So resource planning, and what is the tool used for a hardware, what is the tool used for a software. These are the resources, human resources as well as other resources. You should planning resources according to solve requirements. And then risk management planning also part of a planning. You should concentrate about risk management also. For effective design, you should concentrate about a risk management also. And then analyzing and estimation. We need to define what are the system. So what is the hardware cost, and what is the software cost? How can we reduce the hardware cost? What is the memory size? We can choose how much amount of on-chip memory. We can choose how much amount of off-chip memory. How can we optimize these things? How can we partitioning the memory? And then how can we use a minimum number of ports and everything? So these are known as a cost benefit analysis related with the price of the material. So we need to provide a quality product within minimum price, then only it has market demand. A quality product with a minimum price. So a cost benefit analysis is the key factor for that. We should analyze all these things, and we need to eliminate the unwanted things, unwanted parts from the desired one. And then feasibility study. So before implementing anything, we should analyze the feasibility for that. What is the feasibility, practical implementation, and then what is the feasibility for marketing, everything you need to decide. and then what's the product type we need to design. Finally, we need to design a product type, and after construction, it should be reviewed whether the system satisfy all the requirements, and then whether the cost benefit analysis, based on the cost benefit analysis, whether it is affordable for the customers requirements, customers budget. So everything it should be reviewed, and then performance, everything it should be reviewed, and finally it is approved. So how to analyze the requirements, customer requirements or industrial requirements? So first one, through feasibility study, and what is the investment for that, and what is the return. So it is common for all product development. So what is the investment? What the amount that we are going to invest, and what is the return? Whether the product has a market, or whether the product has improvements, and whether the product can be used for a long period. Everything you need to study. Then only we can invest, and after that we need to find out the returns also, estimation also, return estimation. You need to estimate what is the return, is possible return. Based on the return only, we can invest amount. List of requirements with specifications. What are the devices used? What is the technical specification? Microcontroller means what is the microcontroller we are using? What is the size of the memory? What is the processing speed? What is the clock frequency? What are the I/O devices are required? And what are the interfacing devices are required? What are the software modules? Whether we are developed using open source or other costliest design softwares, everything we need to require based on the specification. With the specification itself, suppose you are choosing the microcontroller, means whether a 8-bit microcontroller is essential to solve, or a 16-bit go for a higher end microcontroller, or you have a memory, means whether it is in 64 KB or 128 KB, everything is decided with specification also. So it is very important. We need to list the requirements with specifications. Then analyze the requirements. For practical implementation, we need to analyze what are the things are there, what are the, whether the requirements has above the budget or within the budget, and then whether the requirements are matched with a hardware and then software. Everything you need to analyze it, and then only we can design a product according to that. So these are the steps, the requirement analysis. So product specification, then hardware specification, software specification, and then mechanical specifications are the various units of product specification. We should specify our products with units like that. Suppose you are designing a mobile phone, means what are the units are used, what's the display size, and then what is the battery, and then what are the sensors are used, memory, whether it is 64 GB or other thing, and then RAM, what is the RAM, it is 6 GB RAM, 4 GB RAM, everything. So these are all known as a hardware specification. Software specification means you are using various versions of software, whether Android versions are there. These are all software specification. So within this budget, within this requirement, what are the optimized hardwares can be used? What are the optimized software can be used? And then other mechanical specification also done. That is the, so they are specify the products, specify the units of products according to the requirements. So design the intended product. So if first, before the final implementation, you should design a prototype. Then partition the prototype design. So embedded system has a major partition of a hardware as well as a software, and then produce a functional modeling of a hardware and then software. Actually, it's not a simple thing. There's a lot of parameters are involved with this. The hardware design means how many devices are there. According to the devices, we need to design a compact devices, means we need to decide about the chip size also. Whether the chip size is matched with the, suppose we are designing a compact devices, means it is expensive, whether it is matched with the budget, and whether it is essential to solve the application. Everything you need to decide. And then software means consider about what are the accessing elements of the software and what is the memory. What is the, they are using a software with a minimum memory. It should be loaded in minimum memory. In case of RTOS means it should be occupy very less memory only. If the OS itself occupy a lot of memory means that is also a concern. So you should concentrate about what are the partition type of prototype design also. Then only we can finalize a product. So these are the very essential elements for designing an intended project. So implement the design. So the final implementation based on the product, you need to choose the hardware components with specification and then design hardware, generate the code and test it, integrate the hardware and software and test. So first, we should choose a hardware components. So first, what is the right thing is, you need to choose a particular microcontroller family for that. Which microcontroller is suitable for that? After that, the operating frequency and then the instruction execution of a microcontroller is purely depending upon the oscillator. So the oscillator is related with the frequency of operation. So we need to know what is the speed expected. So high speed devices mean you should choose a crystal oscillator with a frequency, high frequency. Then only the execution time will be less because a frequency is inversely proportional to time period. If the frequency is more means the time of execution is less. So you should find out what is the maximum suitable oscillator according to this corresponding microcontroller device. Along with this, we need to know what is the size of the memory required. You need to analyze that also. It is depending upon the application software. So what is the memory is required? So you need to choose a on-chip memory according to this because compared with the off-chip memory, on-chip memory is the fastest one. But what is the penalty we need to pay is the price is high. So we need to choose what is the actual requirement of on-chip memory. If the application software requires less amount of memory means it can be chosen, but it should solve the real environment problem. It is solved with the real environment problem. All aspects of real environment problem with a limited memory means it can be chosen. And then you need to design the hardware using a hardware description language. And then you need to code it and test it. All the elements are working properly according to the needs before implementing because a hardware design is the uh, expensive one. So before implementation, you should check each and every module before implementing it. And then final step of embedded system design is you need to integrate the hardware and software. We already designed a hardware. We need to write a code for an application software. Application software means we are solving a particular issue. So we need to write a coding to solve this. We can write a C++ coding to solve a particular thing. What is the thing is essential is we need to integrate. We need to load that program into the chip what we already designed. So after loading, after integrating the software into a hardware, we need to test it whether the device is working properly and whether the device is solving all aspects of our design requirements. Everything we need to concentrate at this implementation part. So then only we can produce a successful device with high performance. So these are the various life cycle models involved in embedded system life cycle models. So waterfall model, you can see like this waterfall model. So the first step is analyze, the second step is design, and the third one implement, verify, deploy, and support. So each units we already discussed about each units, what is analyze, what are the things we are going to design, what are the things involved with the implementation, what is verification, what is deployment, what is support or upgradation, and then maintenance related with this. Everything we already discussed. So now we go for this advantage of this one. So advantage of this waterfall model is easy scheduling and direct and easy to understand the model. So the flow is a sequential one. So we know that what are the things we need to just analyze the customer requirements. After that, based on the analyze, we need to design it, and then we need to implement as a product, and then we need to test our verification, and then deploy that one, and finally we need to support for that product and maintenance as well as upgrade. So this is a sequential one. It's like a waterfall model. So this is easy for scheduling and as well as understanding the concepts. What is the disadvantage for that? All requirements known beforehand. No phase go back and correction. Once the product is developed, there is no need to, there is no way to go back and correction. This is the major disadvantage of that. So if we know all the specifications and we know all the requirements about the product, then this model can be suitable. So this is suitable for routine works like ATMs and other factory control units like that. These models are, we have all the requirements known beforehand. If you are developing a model for a new issue, to solve a new issue, a novel idea, then this model can be worked out, because we need to go for many corrections for that new model. So this model is not suitable for that. It is suitable for a routine factory setting, which doesn't require more modifications. It's a routine one, then it model can be suitable. Then to overcome the limitation of existing this waterfall model, the backflow model is adapted. So what is the thing is, analyze and design, implement and test, everything can be backflow. We go for the previous phase. So we go for a previous phase here. Analyze, after the design, implement and test. If you find any issues during the design, then in backflow, you throw the backflow, we can change it. If you find any difficulties in implementation, we can change it by backflow to design process. If we find any errors, or then in the testing process means we can go to the implementation process and correct it. So what is the difference between the previous model and this model is, we can go to the previous phases through a backflow. So this is the difference. So this is the main thing for this backflow. What's the need for backflow? Why we go for backflow is important one. The customer is not clear about the requirements, what he or she want, and keeps changing in their requirements as the project in progress. The customer modify their requirements during the implementation. During the implementation, they are modify the requirements. Then we go for a backflow. And then new trends and technology appears. We are in the phase of a product development. If a new technology is adopted, if a new technology is incorporated, so we need to modify the design. While working on implementation product, we know that the new technologies arise. It can be work better than the previous technology, means we can modify it. So it's a necessity for a backflow. And designers and developers may be inexperienced in this domain. So they can require a lot of corrections, and then this is also a necessity of a backflow. The iterative model covers and manages these factors very well, and then the risk management is ensured. We can assure a risk management through this backflow. We can solve all the requirements through this backflow means. Suppose we are using a waterfall model means it cannot be solved that one. If you are go for this waterfall model with backflow means we can modify, we can correct, we can go to the previous phases and we can correct our requirements according to that. Whether it is the requirements are changed by the customer, or whether any technology requirements are there or any errors are there, we can go to the previous phases through backflow. This is the V model, verification and validation model. So it's the safe is in V shape. can see what are the concepts of operations are there, what are the requirements and the architecture is there, and what are the elements involved with a detailed design, and then operation and maintenance, system verification, integration and test and verification. These are all related. So the entire process is verification and validation. We can verify and validate the model at each steps. So each phase has corresponding test and validation. That is an important phenomenon. We can validate the system at each phases. Various phases are there. We can validate the system at each phases. Then only we can get the things. Advantages: it emphasizes planning for verification and validation in early stages of development. It deliverable at each stage is tested one. So in this way, it is superior than the other design life cycles. So what are the disadvantages? It does not easily handle dynamic changes in the requirements, because each steps can a time-consuming one. If you are if any modifications are there, means it is a time-consuming one. So it is a difficulty of this one. It can be validate and verify each stage. However, the time-consuming one, this is that does not contain risk analysis activities. It just whether this is implemented according to the particular flow or a particular model means only it verifies. It does not contain about risk analysis activities, which design innovative ideas and other things. So this is the major limitation of this V model, verification and validation model. So this is the spiral life cycle model. The various processes are there: integration, testing, everything. First we start with the product, whether we are getting the requirements, and then we can go for a requirement analysis. What are the things are required to solve this customer requirement, and then other system analysis, and then object analysis, architectural design, various hardwares and softwares related to solve the issues are designed according to the requirements. After then, mechanistics design, and then we go for a final detailed design, and we implement the product using a coding, and then we are integrating the hardware and software, because then only we form an embedded system, and then we validate the product through a testing process. The iterative prototypes, we are designing iterative prototypes. So this is known as a spiral life cycle. So from getting the requirements from the customer to provide a product, the process is we are following this. We are developing many iterative prototypes. So this is known as a spiral life cycle model. This is suitable for innovative applications. The summary of the presentation: the hardware and software can be designed in co-design process. So it should be designed as a co-design process. Once functionality is partitioned as hardware and software, they are designed separately, but there is continuous interaction between the two teams. We cannot isolate the hardware unit from the software unit, because we need to solve a practical limitation only. So according to the limitation, we should we need an interaction between a hardware team as well as a software team. A hardware is tested separately as well as a software is tested separately. However, we need to test again the system after integration process itself. EDLC is similar to SDLC, which is used in the software industry. Software design lifecycle process is there. The EDLC is similar to that. What is the advantages? Here we are handling the hardware also. So various phases we discussed. So totally 8 phases in the EDLC. And then we discussed about the popular models such as Waterfall Model, and then Backflow, and then we go for the verification and validation model and the spiral model. So Waterfall Model, there is no chance to go for a previous phase. It is corrected in the Waterfall Model with Backflow, and then the V model, it is where the each stage we are verify and validate the systems at the each stage, and the final spiral model, it provides a iterative prototypes which is suitable for a innovative systems. Thank you.